Yes, I'm gonna answer your questions about extended functions first. Oh my gracious. Great googly moogly. I have to think about this. I did. The Honda dealership in Columbia, but like Lexington, Columbia.
Wait, I thought we were doing the other stuff first.
This is extended functions.
I thought we were doing the other graph thing.
All right. What other graph thing? What other graph thing?
So sine x over x is 1. We knew that.
We know that the limit as x goes to 0 is 1. How do we know that? We derived that. That's our little friend we talked about, right? So what the extended function we're going to do is sine x over x when x does not equal 0. But what's the value when x does equal 0? What can we plug the hole with? Essentially, we're looking for the limit as we go to 0. 1 when x does equal 0. That will make it continuous. Right? Plug the hole right there. Oh, that's fun. Which other one did y'all say from your homework? 26. Write it for an extended function so that the function is continuous at x equals 1. So I'm going to factor. Are y'all hung up on the... Oh, okay. Look, little parenthesis, big parenthesis. Same change plus. Yes. Change. Always plus. Same change plus. So if you have a cubed minus b cubed, it's a minus b, a squared plus ab plus b squared. And if it's addition, it's a plus b, a squared minus ab plus b squared. Difference or sum of two cubes. I have on my octopus shoes today and they squeak when I walk. Sorry. I call them the octopus shoes because they look like. All right. What times of stuff 3 times gives you x cubed? Yes. I'll show you in just a minute. I can even hang upside down. Well, that's not the right kind. It has to be. This is, see this paint here on this brick? That's the kind it needs to be in order for them to suction really well. All right, so x and 1, x squared, x and 1 over. There's a difference of 2 squares. So the whole is at, well, let's see. If we put 1 in, 1 squared plus 1 over 1 plus 1. The whole is at 3 over 2. Right? Or that's what I need to plug it, right?
But the other hole, I thought when you cross it, you got a hole. So
What?
you cross out x minus 1, don't you get a hole when you do that?
Yes. Oh, yes. There's a hole at x equals 1. You're correct. You're correct. I'm sorry. So I don't think nobody's there. Grandma.
In order to plug the hole, you just
Grandma.
plug in what answer.
So yes, I'm looking. So the way I would write this is I would say f of x equals. I write the original equation, right? X cubed minus 1 over x squared minus 1. This is when x, anytime x is anything except 1, because 1's going to cause a 0 in the denominator, right? When x is 1, I want to put it as 3 over 2. They didn't ask us about that one, though. They didn't ask us. They asked us, didn't they ask us to plug the hole at 1? Yeah. They said plug the hole at 1. Right after it, it said f of x equals x cubed minus 1 over, and then it said x equals 1. Right.
No, I'm not.
We're just looking for finding a point at that undefined point they gave us. It'll make more sense a little bit further as to why we're doing it. Oh, this looks like maybe a double angle thing.
Oh, this thingy can't be doing our stuff.
It's different. Your science stuff.
This is gray is calculator or non-calculator? You sure? Why? Angle with that, but what's sine of 2x? What's that double angle theorem? Sine of 2x equals. Y'all are guessing right now.
I'm gonna be honest, I don't remember this trick. Wait, I can tell you. What are we looking for? Are we just not?
Yeah, put a pin in that one. We'll come back. It's gonna work out. It's gonna manipulate its way back down. That's what it's gonna do. 29 is another trig function. So essentially, what we're doing for these, they rationalize the denominator, is what I'm assuming. Square root of x plus 2 times squared, right? What happens if you do that?
Why did you give us the x equals 4? Why did they give us x equals 4? Just to plug it
Oh, I see. Made it a difference of 2 squares.
What now?
Okay, so
That's a rationalize it.
I would have gotten back there eventually. X minus 4 and square root of x minus 2, right? So since we know, and they tell you x equals what, 4? Is where you're trying to plug. So what they did here was just a little algebraic manipulation. You see that 2 is the square root of 4, right? I can write this as the difference of two squares. Because you solved this one, you would have to make the connection between. You see, I didn't do that initially. My initial reaction was to try to rationalize the denominator. When this didn't work, I'd have went back and looked at it and go, okay, let me see what I can do now. Smart people would probably see that initially, that, oh, that looks like a difference. I wasn't. You see what I'm saying? No, I'm saying I wasn't smart enough to see that to start with. It wasn't a dig at you, Van. I'm sorry. I really wasn't. It was a dig at myself. I didn't see it at first. No, he's not. So then we have the square root of x plus 2. So now if we plug that in, we end up with the square root of 4 plus 2, which is 4. And so our extended function would be equals 4 at 4. Does that make sense? No. Does it make sense after I did it? You just wouldn't see how to start it? Or... So this concept is it's essentially saying we know that here there's a hole at 4. So whatever else this function's doing, there's a hole here, right? We want to make it not have a hole. So what value would we have to plug in so that this filled in here? It's not really what you're doing is you're finding the limit as you approach that is essentially what you're doing. Because remember here, the limit doesn't have to be the same as the function value, right? But what we want is, because that's what it means to be continuous, it's basically testing your knowledge of continuity. To be continuous means the limit as it approaches from both sides equals the function value itself. So what we need to do is, like this was at 4, right? So we need the limit as x approaches 4 of this. You can't just plug in 4, that's exactly right. So we're doing algebraic manipulation so that we can just plug in 4 and get the value. You're talking about the little, I would always do that if it was me doing it. I would always do that with the original function and then plug the hole. Limit, right, whatever that limit is. Yeah, this was set, if I just graph this, there's a hole at 4. And if you put it on your calculator, you'll be undefined at 4. So in order to make it a continuous function, I can't have a hole in a continuous function. So I need to plug the hole. So I need to find the value that would plug it. So that would be the limit as it comes into both sides, because it's a hole, right? So if I find the limit, then I can do it. So this, I can always use substitution for limits if it works, but it doesn't work here because I would end up with 0 on the bottom. So I manipulated it enough where I could plug in and then plug the hole. Does that make sense? I would. Yes, yes. Yeah. Oh, yeah, it's not. I feel like we did this in class.
We did. I missed it because I was actually
30 is like algebra 2 all rolled up in one big ball.
Oh. Look what I got, everybody.
I knew it when you did that something. Always
All right, so this is telling me that at x equals 2, I'm not continuous, and I want to be continuous at that point. Yes, there is another discontinuity in this graph, but that we're not worried about right now. We're worried about making it continuous at x equals 2. Okay, so let's look at, so really remember what this is I want the limit as x approaches 2. That's essentially what I'm looking for here. Does that make sense to everybody? Okay, why it look like you're fixing to go to sleep. All right, so no, I gave it to pre-calculus. Maybe he's not here today. All right. Here, I do. I mean, I'm lying. I do. 2. So I can't do anything the way it is now, but I do notice this. X minus 2, x plus 2. I can't plug in because it'll give me a 0 in the bottom. And so what I really need to cancel out is I need this to cancel out. Do you agree? So I wonder if that is a factor of the top. How could I find out if that was a factor? I would do synthetic division also.
I already know. I forgot. I remember. I said.
You can do long division.
No, I can't do long division either.
No, but look, I'm showing you. Watch how easy this is. Look. Opposite sign. Okay, do synthetic here. 1, 2, -2, -4, -15, -30. Opposite sign, because remember, you're dividing by the 0. So if x minus 2 equals 0, then x equals 2 is the 0. So it's always the opposite sign of the factor, the same sign as the 0. Because it asked me to find it at x equals 2.
No, hold on. Can we finish this synthetic real quick?
I will show you.
So what's the first step for synthetic? You make that little box.
These are the coefficients. Drop it. Add. It's repetitive after that. You multiply, add, multiply, add, multiply, add. This is always your remainder. All right, so this tells me x minus 2 times x squared minus 2x minus 15 over x minus 2, x plus 2, which conveniently enough, there's my hole, so plug the hole. Some teachers do flip their classroom, and in class, but if it's done correctly, you watch the new material at home, and then you come in and you do your homework in class so that you answer questions. Done correct, right? When done correctly, it does work well. It's just ensuring that teenagers are going to go. This one. Because whenever I synthetically divide, think about a regular division problem. It's really, you could rewrite it. If I had 6 divided by 3 equals 2, right? I could write this as, well, 2 times what I divided by gives me what I started with, right? I did the same thing. I divided by x minus 2, and I got x squared minus 2x minus 15. So it's the same thing as what I started with.
Taking the factors that we think will work.
Well, they gave us this. They said make it continuous at x equals 2. So that means I need to find the limit as x approaches 2. And because I couldn't do anything with it, I checked to see what, I knew it was a factor of the bottom. I checked to see if it was a factor of the top, to check for a factor divide. And in this case, it wouldn't work because 4 is not a factor here. But yes. All right, yes. On what? The last two pages?
39 was cool.
Oh, 39. Oh, this is a good one. This is a great one.
It was.
This is your typical multiple choice question. This is 39 on page 97. When you ask what will it look like on the AP exam, I would say that this is a typical page 97. It's on like the last set. Okay. So the question is, what value should be assigned to K to make F continuous? This is the exact same thing we've been doing. It's just worded a little bit differently, and they love to use a K. K shows up all the time for whatever reason. All right, so essentially, what am I going to plug the hole with to make sure this is continuous? Well, remember what that means. That means that the limit as x goes to 3 of this is what I'm going to plug my hole with. Because that is what continuity means. The function value has to be the same as the limit. Does that make sense? Okay. Factor the top. How about x minus 5x plus 3? Ooh. Oh, I copied it wrong. Woo! I was like, oh my gosh, it's not going to work, y'all. Okay, it's going to work. I had that first time wrong. All right, so it goes. So now I want the limit as x goes to 3 of x plus 5, which we know is 8. So in order for this to be continuous, because the limit as I go to 3 is 8, what that means is, all right, so whatever that graph looks like, there's a hole, right? This hole happens at 8. So if I put a value there at 8, it'll plug the hole. $29 on the first or second set.
Yeah, that was.
This one? Dan, control yourself. All right. 29, part A says find the right hand and left hand limits of f at x equals -1, 0, and 1. So the limit as x approaches -1 from the right, and then we're also going to do from the left. What is the limit as x goes to -1 from the right? So the first thing I need to do is figure out which equation applies, right? That's the hardest part about this. -1 from the right but -1 from the right. Right. Greater than -1 from the right. Yes? So -x, which would be -1, which would be 1. Is that what they got? I don't have the answers to this one.
How do you do it?
-1 from the right. So that's bigger than -1. So that's here. So now negative 1 from the left. Huh? I'm just, what I'm doing, what this is. Oh, yeah, this is just telling me which equation to use. So I use the negative x equation. And I'm plugging in negative 1. Negative, negative 1, so the two negatives will cancel and leave you with positive. That's okay. How about negative 1 from the left? It's also 1. It's also 1 because less than negative 1 goes here.
So we look, so like for the first one that asks like what's the limit of -1 from the right, how would we know exactly which one is from this? Just look at it, okay, if it's from the right, then it has to be greater than 1.
Right,
Or
yes.
greater than -1.
That's exactly
So we
what you
look
do.
at the second one.
Yes. This is the exact same problem that was on your quiz, only you've got equations instead of a graph. Mm-hmm. Correct. 0 from the left, the limit as x approaches 0 from the left. I am going to say you're still going to be in this one. Less than 0, yes. Because it's approaching. Remember, the limit from the left and the right only, the function value only equals the limit if the left and right limits are the same. If they're different, then it doesn't necessarily equal the function value. Would you leave her alone? Why are you poking her? So I'm going to say that this is negative x, which in this case is still just 0. Does that make sense? How about 0 from the right? It is. You have to really think about it. So 0 from the right means x is bigger than 0. Bless you. Which is negative x again, which is 0.
But you said.
Remember limits. We want to use substitution if we can. So this is the value I'm subbing in for x.
But you did every x there. On the one where it's -1 from the left, we use the second equation plugging it into it also.
Yes.
1 from the left.
1 from the left, the limit as x goes to 1 from the left. That's less than 1. Yes, this one. So it's negative 1.
How did I use the first one?
From the left of 1, which means less than 1.
Can you go back up? What about that one? That's x is less or equal to -1. Oh, because we're not talking about -1.
We're not talking about negative 1, we're talking about positive 1, right?
I really don't think about these.
You do, and that's the thing. This is another typical type question that they would give you.
This makes a lot of sense now. Like, I understand. I just had no idea what makes sense.
I understand. That's okay. 1 from the right, of course, would be that last equation. Greater than. Let's take a. Whatever you. I just pick up from Friday. I'm going to pick. I don't remember what problem I was working.
No, I like that color. It works out really smoothly. They'll ask you to teach it to you later.
All right, so just as a recap real quick, we talked about the difference in a secant line and a tan line, yes? Okay.
Wait, yeah,
Get on the right page. Secant intersects, excuse me, twice. Tan line intersects once. The slope of the tan line gets closer and closer and closer to the slope of the tangent line as the points get closer and closer together, right? You remember, I'm trying to get that distance apart to be 0. That's the point of the tan line, so that it only intersects in one place. Somebody, anyone, just to see if you remember, what is this? Yes.
Quotient of f of
F
x
of
plus
Same
a
A-Rod thing.
minus f of x over h.
Stupid difference quotient. I hate it. I still don't know how to do it. I'm gonna look it up after class.
Wait, so
I messed it up on the quiz. I had no clue how to do it.
A-Rock is slope.
Difference quotient
But I messed it up.
Okay, so this is A-Rock without the limit on it. When you put the limit on it, it becomes I-Rock.
it's like instead of being the average, it's
I understand the concept. I just don't know how to do it.
Okay, well, let's do it because you'll have to do that for the secant line. So let's do one real quick. Let's look at f of x equals 2 plus, we're doing an A-Rock for Van. It's actually from your homework. Number 6. Find the average rate of change over the interval.
Where's that little symbol?
A. It's just part A of the question. Average rate of change of the. Find the average rate of change over the interval.
I don't want to answer that. Shame on you.
What are y'all forgetting? Why are y'all doing cosine of 1? I hear y'all saying cosine of 1.
I ain't even tried to do anything yet because I don't know how to do it.
This is the interval that I want to use. So to do an interval, right, that means I'm using f of 0 and f of pi. It is hot in here. What's the cosine of 0? What's the cosine of pi? What points am I using to find the average rate of change of the Why are you graphing it? Why are you graphing it? No, I don't know. I'm just asking why you're graphing it.
Well, because I grabbed, because I heard the cosine is negative 1 and 1, and then.
I think you're overthinking this. Did you?
Not exactly. That's great.
So 3 minus 1 over 0 minus pi. The average rate of change over that interval is negative 2 over pi. Average rate of change is the slope between 2 points. And this said on the interval 0 to pi. That means when x goes from 0 to pi. So I need my endpoints. So to find those endpoints, I plug them in to find these values.
I might also, I understand that. I might get you to,
I'll do another one.
show me the one I messed up on.
Okay. Write the equation. Are y'all ready for this? This is not part of this question on the homework, but we're going to do it now. Write the equation of the secant line that goes through these 2 points? Write the equation of the secant line that goes through these 2 points. It's the same thing, so what am I doing? I'm just in a fancy way asking you to write the equation of the line that goes through these 2 points, and I've already found the slope for you. Tan, that's right. Use whichever one you want to. Y minus y1 equals slope x minus x1. This is the secant line on this interval through those 2 points. What do you mean? That's the point slope form of a line. I just used. Are y'all ready for this? Actually, let's do the other half of this, and then we'll move on to the tan one. Find the average rate of change, same function. You do this one on your own. Find the average rate of change over the interval negative pi to pi. Yeah, this is part B.
It's just saying.
Well, yes. Think about my circle, right? Here is pi. Here is negative pi. I'm at the same point. Let's do it. Let's see what happens. This is 1, which means f of pi is also going to be 1 because we said those are ending up at the same place, right? So we have
Wait, I thought at negative pi, the cosine value
It's a minus 1. Oh my gosh.
Negative pi, so pi's over here, if it's negative pi, will be on this side.
yeah, that's what I believe.
so if it's
You always start at 0.
you always start at 0, right? To get to pi, I'm here.
Right?
To get to negative pi, I start at 0 and go counterclock or go clockwise pi. I end up at the same place. Because that's exactly half the circle. So no matter if I go this way or this way, if I go half the circle, I'm going to end up at the same place.
So you start at 0 and go the opposite way, so you get to that point.
Yes. Are y'all okay? All right. I want to look at this one more time. I want to go back to part A because I want you to do something for me. I want you to find the average rate of change using the difference quotient instead of using delta y over delta x. I want you to see how it still works for part A. So remember that difference quotient? F of x plus h minus f of x over h. What am I using for x and what am I using for h? All right, so this is the difference. The difference between the two x's, right?
0.01.
This is my starting x. So what is this going to be? 0 in for x, that's exactly right. So I'm going to do f of 0 plus, what's the difference from 0 to pi? How far is that? It's pi. Minus f of 0, because I'm using that x as my start, and my difference is pi. Hopefully, I come back to negative 2 over pi. I just want to show you that it's the same thing, that we're doing the same thing. The difference quotient can still be used, that you're still finding. What I'm really trying to get you to do is make the connection between the slope of the secant line, and as that difference gets closer and closer, you end up with the slope of the tan line. That's my goal, is for you to really understand anyway. And that essentially, even though we don't use the formula this way, we could. And so as we use it for tangent, why it still works for the slope. This equation is still the same. So it's 2 plus cosine x. So it would be 2 plus cosine of 0 plus pi minus 2 plus cosine 0 over pi. Say again? Yes. That's right. You'd have to subtract them. Okay. Y'all realize that, right? This is not just the y value. That's the difference in the 2 points, the width of the interval. Go ahead.
The second part, you did up top with the parentheses, did 2 plus cosine 0. Why wouldn't the 0 just be in parentheses by itself?
Which part?
Like right here.
Wouldn't it be 2 plus cosine, then parentheses 0, parentheses?
Yeah. Like that.
Yes.
Now, not that you have to do this for A-Rock, so if you're looking at it going, oh my gosh, yeah. Okay, so what this is where I start in my interval. That's the very first point in my interval. So that was 0. This is if you take your start, I should actually say your 2 endpoints, the difference of the 2 endpoints in your interval. So in other words, over here it would be pi minus 0. What should be pi? This one? This one. Okay, so my f of x is 2 plus cosine of x. So if I want f of 0 plus x, or 0 plus pi, that means I just changed the x to be 0 plus pi. All right. I took way too long on that, and I apologize.
Oh, we don't. Let's go. I'm going to the Carolina. Dude, my dad's trying to make me go to my cousin's wedding. I'm like, no, I'm not serious.
All right. The difference in the tan line and the secant line is the tangent line is the limit as h goes to 0 of that very same difference quotient. So it's the same. The only difference is my distance, my difference between start and end point is 0. Okay, so I'm going to find the limit as h goes to 0. So no difference here, but I'm going to go through the same thing writing these equations. So I want to run through number 10 with you, because for number 10, we're going to write the equation of the tangent line, and we're going to write the equation of the normal line. What does normal line mean? Does anybody know? Did we talk about this Friday?
Oh, yeah, normal line. Yeah, it's perpendicular to 10.
And perpendicular means, that's right. So what I want to do, and hopefully I got time to get through this one problem, what we're going to do is we're going to find the slope of the curve. We're going to find, given one equation, we're going to find the slope of the curve. We're going to find the equation of the tan line. We're going to find the equation of the normal line. And that's all. We'll do both. We'll do both. In 7 minutes. This is number 10 from your homework. Yes. Did you or can you? Oh, yeah. It's okay. At x equals 1. So what I want to do is I want to write the equation of the tangent line at x equals 1. So before I can write the equation of the tan line, I need anybody. Not a rock. I rock, because tan line is I rock. And I rock's going to give me the slope of my line, right? I rock equals the slope of the tan line. And as I do this, I am going to use my difference quotient. So I do the limit as h approaches 0 of f of x plus h minus f of x over h. But what is x? 1. It tells me where to start, right? So I put a 1 here, and I put a 1 here. Y'all all okay there? Okay. So f of 1 plus h minus f of 1 over h, and I didn't mean to put, this is where they'll dock you a point. This is what they were talking about on the thing, how I just put it equals that. It does not equal that. I forgot my limit there. F of x is x squared minus 4x, right? So I'm going to put 1 plus h in for the x's, right? 1 plus h squared minus, when we get to 3, 1 and y'all see the shortcut that I show you, you'll be so mad. Wait. Oh, you do. They test you on difference quotient for sure. I'm just going to do this over here. F of 1 is 1 squared minus 4 times 1. F of 1 is plugging 1 into this. Are y'all confused? Okay. This, instead of doing it on the same line, I just came out to the side. Yes, it's going to end up being plus 3. I just wanted you to see that. We were a bit rushed with it. Where are you confused?
Oh, then you're going to
F of 1 equals, right? I have to keep going back. I'm going to change this to f of x. Yes.
Where I get confused is the first, at the bottom part, like the first 2 things. Like, how do you get that? I know it's like f of x plus h, but all of that.
So I did f of 1 plus h, because that's here, right? So if f of x is x squared minus 4x, then f of 1 plus h is 1 plus h squared minus 4 times 1 plus h. These x's go away and become 1 plus h. Remember, it doesn't matter what's in this parentheses, it replaces the x in the equation. If that was f of van, it would be van squared minus 4 times van. It doesn't matter what it is. If I FOIL this out and distribute that negative 4, magic starts to happen, as it always will in these kind of problems. 3 and 1 makes 4, and I've got a negative 4 there. And now suddenly everybody has an h to give. H, 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 H. So I end up with the limit as h goes to 0 of 2 plus h minus 4, the bottom's column. Yeah. What did I just find? Which is the slope of the tan line at x equals what? What was it, 1? Can you write the equation of the tan line now? While I'm right here, what's the slope of the normal line? Positive 1 over 2. You need a point and a slope, yes? You've got a slope, you need a point. I need the point to be x equals 1, so I need the y that goes with that. Do you agree? Y equals, what is it? X squared minus 4x. So you've got the point 1, negative 3, and you've got a slope, and you write the equation. Yeah, go ahead. Normal line, notice the difference is the slope in the normal line and the tan line. I'll post your homework. I could give it to you now, but you don't have the pages on here. But I'll post it, and it will definitely be there